Brad threw me a little bit of a curve. I got here in a rush from another conference, and he said that I only had 21 minutes to deliver my 32 slides. So I'm going to have to talk really fast, which means I'm going to skip some things. 12 things. 12 minutes. Oh, there's that dyslexia again. So I think most of you might know who we are, but we're hardware specialists and software specialists in terms of measuring the market sizes of things. And we write reports and do consulting and lots of conferences. Engineering software runs on a variety of platforms. It wasn't always like this. It used to be that it ran on workstations, and then it started to run on PCs, and now it runs on just about anything that has a reasonable CPU in it. And I didn't see anybody laugh, so I guess you're all asleep. So here's a quick look at the hardware shipments. It's hard for me to see the slides up there, but as you can see, the PC is clearly a dominant machine. What? Ah, God, modern technology. It's amazing. I wondered why he kept looking at the floor. I thought he was trying to think. So anyway, you can see that the PC is clearly the big guy in the market. Now, these numbers are not raw unit numbers. These are weighted numbers, so we try to weight it in terms of the product being, the hardware being used with regard to the application. If you just used weighted numbers, then of course mobile devices would swamp it. You wouldn't even see workstations on the market, on the chart. Part of the growth that we forecasted in last chart, is due to a rash of new hardware product introductions, new CPUs, which is being enabled by the move from 28 to 14 and 16 nanometer by excuse me, three major fabs, Intel, TSMC, and Samsung. And so they're providing processors and fab services for the major companies. And as a result, we are having and will continue to have this entire year a rash of new processors. Intel announced their Skylake processor late last year, early this year. And just 2 days ago, NVIDIA announced their new Pascal processor, which is built on 16 nanometers. AMD will be announcing their new processors this fall. Just a couple of months ago, Qualcomm announced a new processor, the 820, and their competitor MediaTek as well. So lots and lots of new silicon. And the good news is that Moore's Law continues to work. It's not quite as economically efficient as it used to be, but it does continue to work. The processors are getting smaller, simultaneously getting faster, and also able to address more memory. The memory as well is getting smaller, faster, and cheaper, breaks the rule. So the net result is that for engineering models, we are able now to stuff more information, more data of the data set into the local memory. And that's very important because that really, really improves the acceleration possibilities that we can take advantage of these processors with. If you have to keep getting off chip and out to disk and back and forth and so forth, processor can be a speed at light, but it won't help you if you have to do all those back and forth transfers. So we're putting more and more memory into the systems that we build, and the net result is that we can keep the model inside and manipulate it inside. As you can see, the memory is going faster and faster, and tablet memory is moving up in speed as well. Almost all PCs in workstation class, and all workstations for sure, are now employing SSD, solid-state drives, and they give us a nice speed improvement. They help load the program faster, and if the data is stored there, the model, then that gives you a nice speed bump as well. So the net result of all that is that we can have bigger models, which is the trend, and our productivity can go up simultaneously. And then if you're doing rendering, then the rendering time goes up as well, or goes down, I should say. Now, there's a funny rule about rendering is that rendering time never changes. And the reason it never changes is because as soon as we can get 5 more cycles to do some rendering, we just make the picture prettier and make it more complex. And I like that personally because we are making truly beautiful pictures. Which number am I looking at, the most significant or least significant? It says 7, 11. Am I got minutes or seconds?
7 minutes.
Oh, okay, thanks. God, I'm out of time already. It's just got here. The other thing that happened in late 2015 and is being deployed in 2016 is higher speed inter-box communications. And this is really interesting and I think a little bit exciting in that we now, again, due to Moore's Law, can create enormously high-speed inter-box communications. And this has a broad range of opportunities for us, not the least of which is that we can have faster external disks, we can have super high-res external monitors, and we even can go PC to PC or workstation to workstation. So we now have, with USB-C, the equivalent of a super, super high-speed LAN capability. And the only piece that's missing there, and that's coming really, really fast, is the software stack to take advantage of that particular port. So here's a perfect example of Moore's Law marching on and serving all of us. Moore's Law is still our friend. The other thing that happened in 2015 and is moving on to 2016 is DisplayPort, which I think kicked off about 6 or 7 years ago, has now gotten to the next step, and the next step is it's lightningly fast, and they've increased the connector, you can see it there, they've increased the connector so it's got fatter pins now, so it can carry more power. So the combination of that, the combination of a new lossless compression scheme that's being part of the spec gives us a bunch of advantages in the monitor. So it's now going to be possible, and I think you'll see the first implementation of this probably late this year, if not first thing next year at CES, will be monitors probably about 17 inches, I think that's as far as they'll push it right now, that will not have a power cord. And you'll just plug them into your computer with a DisplayPort connector, and they'll draw power from that connector as well as signals. And the thing that's making that a variable in terms of when we can do that is the resolution of the screen, whether we can do it at 4K or not. I personally think we can. And whether we can drive a large enough screen to light it up with the power that we can get out of there. OLEDs are helping the lighting up part a great deal. Oh, and daisy chaining, and that's the other neat thing, is that you can now connect monitors to monitors to monitors to monitors. So if you're building a wall for some reason, for a control room, or if you just like to have a lot of monitors like I do, you don't have to run a whole bunch of cables from a whole bunch of graphics boards anymore. You can do one cable to the first monitor, it daisy chains to the second and the third and so forth, and you can do an extended desktop across all that. The displays are getting bigger. If anybody here even remembers what VGA is, I pray that you're not using it. I gave a presentation the other day, and there was a VGA connector, and I went, oh, crap. I haven't had a VGA cable, and I don't know what to do with this. Unfortunately, they had an adapter. But it served us well for a very long time. It's gone, finally. The average monitors today, and this is average that's being sold, is about 27-inch. That's probably pretty good. For someone who's doing serious engineering, I don't think it's quite good enough, but then you put a couple of them out there. The average resolution, however, is only HD 1080p, which I think is abysmal. You know, HD was introduced 15 years ago, and it's time we moved on. Power users, however, have moved on, and they're using monitors with either 1440 lines or 2160 lines. And in addition to that, the portable or the notebook workstations with 15 and 17-inch screens are now delivering 4K. We just tested a 17-inch 4K system from a workstation company called Eurocom. This sucker was that big and it weighed about 10 pounds. I was like, yeah, that's a portable computer. But it was amazing, had a Xeon processor and everything. You can even get tablets now that are 4K, so there's really no excuse to not have high res, and you can now use tablets as a secondary screen. So you have the ability to spread yourself out. If you're a road warrior and you carry a tablet as a reader, for example, and you carry a notebook, now you can have more screen space while you're on the road. The thing you want to think about when you're talking about monitors, excuse me, is the resolution and the screen size, and from that you derive what's called PPI, or pixels per inch. And it's pixels per inch that your eye cares about. This is how you are going to discern detail on the screen. And this is what 28.8 megapixels looks like, over 78 inches. Now, this is my workstation, and when I'm on the road, I miss this puppy desperately. That's three 30-inch 4K screens, and that might sound like I'm showing off. That's not an expensive rig. It's easily affordable. Those monitors are now about $1,000 a piece, and if your living is processing information, then this is your tool set. You invest in your tools. When I'm on the road, I have to suffer down to 4K. So you can get a 4K 15-inch laptop from Dell now. They just started shipping them this year. That's only about $2,000, and it's got a discrete GPU in it, and it's got a Skylake processor in it, and a load of memory. It has a terabyte of SSD in that thing. So, I mean, it's almost like I really don't need my workstation. I just hang the monitors off of that. And this is the year of color. You're going to hear HDR, high definition, or high dynamic range. I'll get to it. And the idea here is that with the 4K screens, we can go to 10-bit color. And what that means is that we go from 15 million colors to 500 gazillion colors. And why you want that is because you want to be able to see the very brights and the very darks at the same time. And with the OLED displays, you can see really, really good black. You can tell if you have an OLED display or not. And when it's turned on, if you can't see any difference between the screen and the bezel, then that's an OLED. That's black, black, black. And I think I'm going to make it just in time. Yeah. So VR, you can't give a presentation today without saying VR. Okay, I said it. So you've heard VR. If you're interested in VR and AR, I'm going to give a little talk tomorrow afternoon at a roundtable, and I invite you all to come, and did it on time.